Welcome to this FP2 video on using graphs to solve inequalities. So in the last video we used algebra, but even though we used algebra we still had to do a sketch at the end. Now this time what we're going to do is effectively do a sketch at the start. So, without rearranging any of the inequalities, sketch the two of them and then compare them. But we will have to do a little bit of algebra because we'll always need to know the points of intersection. So say I have something like this, then what I can do is before I do anything, I can sketch both of these graphs. So y equals y equals 5x over 2x plus 1 and y equals 2 minus x. And when I sketch the two graphs, which the first one will be some sort of asymptote, something like that, and then the 2 minus x will be something like that. Okay, but we'll still need these 2 points, these 2 coordinates. Okay, so we'll still need to do some algebra even though we're using graphs now to solve them, but primarily the graphs first. We'll do less algebra to get to our answers, and that's really like the aim of this video compared to the last video. It's just taking a different approach to solving the inequalities. Now it's far easier to explain with an example, so let's jump into the first one. So here we have our example and we've broken it down to A, B and C. And what we're looking at is sketching the graphs, finding the intersection and then writing down the solutions. So let's start with sketching the graphs. So the first graph, y equals x minus 2, is a really easy graph to sketch. But this graph, y equals, now we got 6 brackets, 2 minus x over x plus 2, x minus 3. This one's a bit more challenging to sketch. So let's look at that one first of all. Well, actually, let's do the y equals x minus 2 first because that is really easy. So y equals x minus 2 is going to cross the axes at the y-axis at 0 minus 2, and then it's going to cross the x-axis at 2, 0. So just putting in x equals 0 and putting in y equals 0, and that will give me the coordinates there. Now let's move on to the next one. So 6, 2 minus x over x plus 2, x minus 3. So we know when x is 2, so when x is 2, this is 0, the top of a fraction is 0, the whole thing is 0. So y is 0. So it's going to cross the x-axis at 2, 0. Now it's going to cross the y-axis at 0. So we put 0 in for x and we get 12 on the top and we get 2 times minus 3 on the bottom. So we got 12 over minus 6. Okay, so that's going to cross there at minus 2. So we actually got our 2 sets of intersection, haven't we? Just by chance, but that isn't always going to be the case. Now, what does this graph look like? This one's a straight line, this one's not a straight line. But we can see there's going to be some asymptotes. So when x is minus 2, that can't exist, that's going to be an asymptote, and when x is 3, that's going to be an asymptote. So let me start off by just putting a sketch down. So let's sketch our axes. like so. So we've got our axes sketched, and we want x being minus 2 is going to be 1 asymptote. And when x is 3, that's going to be another asymptote. And that's obviously 0 there. So we know that this is going to be, it's going to have 2 asymptotes. Now this one, just by looking at it, is probably going to be something similar to like a 1 over x graph. But with 2 asymptotes, that's not going to be totally the case. So what we need to do is we need to look at what's happening after 3, what's happening below minus 2, and what's happening between minus 2 and 3. We know it's going to cross at 2, 0. So if I mark that on there, 2, 0, and we know it's going to cross at 0, minus 2. So I'll mark both of those on the graph there. It's not quite the same distance away. Maybe that one's a little bit better. Okay, so I've marked those values on there. Now let's go ahead now and try and work out what's happening. So if I put a value in greater than 3, so say 4, this on the top here, this is going to be negative. This is going to be positive, and this is going to be positive. So I'm going to have a negative value altogether. So any value above 3 is going to mean that the bottom stay positive and the top is negative. So whatever's happening is happening under the x-axis. Now, as this heads towards infinity, you know, we're going to have basically negative infinity on the top over 2 lots of positive infinities on the bottom. Okay, so this is going to effectively head probably towards the 0. Okay, when I look at very small values like say 3.1, now if I put 3.1 in here, we'll have 1.1, so 6 times 1.1 is 6.6. Now if I divide that by, you know, 5.1 times 0.1, then that's going to give me, you know, 6 over, roughly 6 over 12, isn't it? It's going to be a half. So I think this is going to be something like this, an exponential graph, like not an exponential, like a reciprocal. So something like this. Okay, I can check with some more values to be sure, but that is roughly what I'm going to get. Now looking at below minus 2, so say let's put in negative 3. 2 minus minus 3 is going to be 5. 5 times 6 is going to be 30. Okay. Then if I put in minus 3 plus 2 is minus 1. Minus 3 is minus 6. Minus 1 times minus 6 is going to be plus 6. So, you know, if I'm putting in minus 3, I'm going to get roughly 5. So maybe somewhere up here. Now, if I put in a larger value, so heading towards negative infinity, this is going to become very large, and this is going to become very large. And 2 very large numbers divided by each other is going to be heading like towards 1 and then potentially below it. So this should give me a graph that looks like that. And again, I can put in very small values like minus 2.001 into my calculator to find out what's happening up there. And I can substitute very large numbers into my calculator to check on what's happening down this end. So I put in 2.000001 in and I got like 48 million. Okay, if I put in a very large number, say I put in 100, or should I say minus 100, then I get 0.060. Okay, so as I put in larger values in, it's getting smaller. So just practice, if you're not sure, think about what's happening as it's heading towards infinity, positive infinity and negative infinity. And again, then if you're still not sure, substitute values in. So substitute very small values next to this and substitute large values away from it. So we've got now what's happening here and what's happening here. We need to work out what's happening between minus 2 and 3. Okay, now we know it crosses at 2 here. So we want to find out what's happening between 2 and 3. Is this above or below the axes? So putting in values close to 2 gives me a very small value, and putting in values close to the 3 gives me larger values. So this is going to be heading up like this. Now we need to look at what's happening between the 2 and the 0. So I'm assuming it's going to be some sort of slope down to this value here where it crosses. Yeah, checking my calculator, it does make this kind of shape. And then between the 0 and the minus 2. And I can confirm that this carries on down like that. And then all that's left is to put in our y equals x minus 2. So y equals x minus 2, which I'll write in red there. So I've done part A. I've sketched both graphs. Now part B, find the intersection. Well, I've already found the intersection. So normally I'd have to make them equals and then solve. But in this case, we found the intersection is 0, minus 2, and 2, 0. And that's what it looks like. However, I'm not 100% sure whether I've sketched this little bit in the middle the right way. It might actually go underneath. So this sketch might have actually gone like this and up. Okay, and I'm not entirely sure if this is above the line here or below the line or what's happening. So let's actually make these two equal just to check in case there is more than 2 points of intersection. So that means we put our x minus 2 equals 6, 2 minus x over x plus 2, x minus 3. Now it's not an inequality, so I can just multiply it out. So I've got x plus 2, x minus 3, x minus 2 equals 6, 2 minus x. Now take in things to this side. We've got this scenario happening. And then finally, this bracket is very similar to this bracket. If I times this by minus 1, I get x minus 2, which would be like this one. So what I can do is Let's change this to a plus 6, and then this is an x minus 2. And then I can factorize. So I'll take the x minus 2 out, and then I've got x plus 2, x minus 3, plus 6. So x minus 2, and then I've got x squared, minus 3x plus 2x is minus x, minus 6 plus 6. So I've got x minus 2, and then I've got x squared minus x. So taking an x out, I've got x minus 1, x minus 2. So this tells me that x equals 0, x equals 1, and x equals 2. Now, I only thought we had x equals 0 and x equals 2. So I've got this other one, x equals 1. So we know the coordinates of this one is 0, minus 2, and we know this one is 2, 0. Now, substituting 1 into my original, one of my originals, so I can substitute it into this one. For example, y equals x minus 2. Substitute 1 in here, we get 1 minus 2 is minus 1. So this is 1 minus 1. So 1 minus 1. So there is a third point there. So this graph actually crosses in an additional place. So that there fits in with the current shapes of this graph and this one, you know, so going down like a turning point there and then going up. Okay, I haven't done this particularly smooth, but you kind of get the picture. This should be smooth down and this one should be smooth up. Okay, so that is our graph done, and obviously, you know, getting the points of intersection really clarified the diagram for my, you know, my graph. And again, you know, if you weren't sure whether this went above or below here, you could pick a point between these 2 points and substitute it in and see what happens, whether this value is above this value or not. But judging by the shapes of the graph afterwards, then this is what I would expect to see. So part C now, we want write down the solution to the inequality when x minus 2 is less than or equal to 6 brackets 2 minus x over x plus 2x minus 3. So we want when the black graph is equal to or above, larger than, above the red graph. So we've got it between 2 and 3. So when x is between 2 and 3, and it can also be equal to, so this one is equals, but 3 isn't equals because 3 is the asymptote. And then between 2 and 1, it's below it, and then between 1 and 0, it's above it. So it's between 0 and 1, and then everything less than minus 2, the black is above the red. And the third one then is x is less than minus 2. So we've got 3 regions where the black graph is greater than or equal to the red graph. I hope you followed that example there. It was quite a long one and quite a complicated graph. I promise you they won't all be this complicated, but this is a past exam question, and because it was complicated, I wanted to do it as an example. Okay, now because this example took a while, we will jump into some questions for you to try. But before that, if you found this video useful so far, hit the like button. If you're yet to subscribe, hit the subscribe button. And if you're willing and able to help me out financially, hit the join button. Otherwise, let's get into the questions. So 3 questions for you, all taking the same format: sketch, intersection, and then the solution to the inequality. So pause the video now. Welcome back. So hopefully you've had a chance and you've completed these 3 questions. But if not, we'll have a look at the solutions next. Okay, so question 1, part A. We've got 2 graphs, y equals x minus 1 and y equals 4 over x minus 1. So we need to sketch these. So for the y equals x minus 1, when x is 0, y is minus 1. And when y is 0, x is 1. Okay, so that's my kind of first graph drawn. Now for the second one, we've got y equals 4 over x minus 1. So it's going to have asymptotes, and it's going to asymptote at x equals 1. So through this point here is the asymptote. Okay, at x equals 1. Because obviously when I substitute 1 in, the bottom of this will be infinity, will be 0, so this will be like infinity. Now what's happening to the left of my 1? So let's look at what's happening to the left. Let's look at what happens when x equals 0. So when x is 0, y is 4 over minus 1, so minus 4. So it's going to cross somewhere like down here. And it's heading towards, if I'm going this way, like if I put in a half, we've got a half minus 1, so minus a half, which will be minus 8, so it'll be lower. So this is going down towards this value here. So I've got this going up, crossing through the minus 4, crosses there, and it's going up towards my x-axis. Then this one should be coming down like this, because our horizontal asymptote is the x-axis. I can see that from the graph. So as my values of x increase, so head towards infinity. Okay, so as it heads towards, the 1 is infinity, because it's going to be 4 over 0, so it's going to be infinity. So just the other side of it now is going to be a very large number. So if I put 0.00001 into my calculator, minus 1, I get, a very large number, 1.000001, for example. So this is going to be very large up here. This is going to come down, cross somewhere, and head down towards the x-axis there. So that is my sketch done for part A. Now part B, the points of intersection. I can see there's going to be 2 intersection points. This one's nice and easy. Okay, in that terms. So I make both of my graphs equal to each other. Now I don't have to multiply by this squared because it's not an inequality. So I can just multiply by it. And we've got this. Now I could expand and then, simplify and so on. But I can see that that 4 is a square number. So if I take the square root, I got x minus 1 equals plus or minus 2. So x equals 1 plus or minus 2. So x equals 1 plus 2 is 3. Or x equals 1 minus 2 is minus 1. So those are my two x values. Now substituting these two into this graph, as it's the easier one, will give me the y values. So substituting 3 in, 3 minus 1 is 2. So the coordinates here are 3, 2. And minus 1 is minus 2. So minus 1, minus 2 is my other coordinates there. Now on to part C, the solutions. So we want when our linear graph is greater than our reciprocal graph. So from this point of intersection to the right, it is greater than. So x is greater than, and that point of intersection there is 3. So that one works. Okay. Then it's greater than this part of the graph. So from this intersection all the way up to 1. So this intersection's at minus 1. So it's greater than from minus 1 to 1. And those are the only two regions where the linear graph is above the reciprocal graph. Now, it doesn't say so in this case, but sometimes it asks for it in set form. So, in set notation, we'd have this scenario here. Okay, so that is it in set form. And another way of writing this would be it's between minus 1 and 1 and between 3 and infinity. I can put a U for the or there. So that's another way of writing it, but personally I don't generally write them like this purely because it looks very close to coordinates. Okay, I prefer just writing this, but it depends on the question, depends on what exam board you're doing as well. If you're not doing Edexcel and you're watching this video, then you might very well do it this way. Anyway, that's question 1 done. Let's look at question 2. So we've got two graphs, y equals 3x over 2 minus x and y equals 4x over x minus 1 squared. Now we're going to have asymptotes here. So let's start off with this first graph here. So it's going to have a vertical asymptote at x equals 2. So x equals 2. So let me mark 1 in, 2 in. I'll put a 3 in there. Oh, let's put the 0 in. So there's my vertical asymptote. And this one then is also going to have a horizontal asymptote. Okay, so what is that? Now, it's not very obvious what it is, but if I look at the graph, I've got this. Now, if looking at the right hand side, if I've got my top and my bottom of the fraction, as long as I multiply or divide by the same thing, it will stay equal. So what I'm going to do is divide by x. So if I divide by x, I get 3, 2 over x minus 1. Okay, now in theory this is equivalent to this one. And why have I done this? Well, quite simple. As x tends towards negative infinity, then this 2 over negative infinity is going to be a very small negative number, but basically it's going to be 0. So we get 3 over minus 1. So that's minus 3. And if it heads towards positive infinity, then this is going to be a very small positive number, basically 0. So this is heading towards 3 over minus 1, so minus 3. So y equaling minus 3 is going to be my other asymptote. So here we have my second asymptote here. So that's at minus 1, minus 2, minus 3. So I've got two asymptotes. I can pretty much go ahead and work out what the graph is doing, but let's also look at where it's crossing the axes. So when x equals 0, it crosses at 0. So 0 over anything is 0. So it's going to cross at 0, 0. And when, we don't need to do when y equals 0 because, we've already got it crossing at 0, 0. So let's have a look at what's happening as it's heading towards the 2. And then we'll look at what's happening the other side here. So this one, as it's heading towards the 2, so if I put in 1, I get 3 over 1, so 3. So at 1, it's here, it's 3. If I put in 1.5, 3 times 1.5 is 4.5, divided by 2 minus 1.5, which is a half, it'll be 9, so it's even higher. So this is heading up this way, so it's heading down that way. So this graph is going to be something like this, which means that we're expecting this one to look like that. And again, you can substitute values in just past the 2 to see what's happening here. Now, with the second graph, we've got a vertical asymptote at 1, because that bottom one, we got the x minus 1 there. So this graph is going to be done in purple. So we've got vertical asymptote at 1. And then have we got a horizontal asymptote? So I'll write it out and I can divide through by x and get this. So as x tends towards infinity, we get infinity minus 2, and this will be 0. So 4 over infinity, which is very large, is going to be very small. So this is going to be tending towards, so the y is tending towards 0. Okay, and if I looked at negative infinity, this x would be negative. Negative infinity minus 2 ain't going to change it, plus effectively 0. So this is 4 over negative infinity, which is, you know, a negative value, but effectively 0, isn't it? Okay, so as it goes to plus or minus infinity, it would tend towards 0. So the horizontal asymptote is just the x-axis. Okay, so I don't have to worry about a horizontal asymptote there. Sorry, a separate one, it's just the axes. Now, what's the shape of this graph? Because having it an x and over x minus 1 squared is going to mean that it's not a straightforward graph, isn't it? So substituting in a value close to that 1, so like I use 0.9, gives me a large value, so I know it's going to be coming down this way. So I know it's coming down this way. It goes through 0, 0, because this on the top here, when x is 0, this whole thing is 0, so y is 0 as well. But it's what's happening here, this side of the line. Okay, and this being the squared on the bottom means that this value on the bottom is going to increase quicker, isn't it? So what's happening here is it going to go straight like this, or is it going to go below and then above? Okay, because it's not heading towards this as an asymptote, it's heading towards this as an asymptote. So if it crosses 0, 0, it can't just then head towards this. So I suspect it goes down, crosses, and then heads up towards this one. So something like that. Okay, so if I'm right, then when we do the second part, we should have 2 points of intersection. Okay, 0, 0, and a negative value here. Now what's happening the other side of the asymptote, it should be something like this scenario there. With the bottom being squared, there's going to be no negative values here. Okay, for the positive x, it's just going to be m positive on the bottom, isn't it? So these are going to be heading towards the asymptote y equals 0 from above. So that is that graph completed. So I'll leave it like that for now. Let's move on to part B. So 3x over 2 minus x equals 4x over x minus 1 squared. So that is 3x, x minus 1 squared, 4x and 2 minus x. So if I take everything to one side, let's actually expand that. X squared minus 2x plus 1. Factorize out the x, so we get 3x squared minus 6x plus 3 minus 8 plus 4x. So that's x, and then we've got 3x squared minus 2x plus 5. Sorry, that's minus 5. Okay, so can we factorize this? The answer is yes. 3x minus 5, x minus 1, I think, or x plus 1. 3x squared plus 3x minus 5x is minus 2x and minus 5. So that is my scenario. So there's actually 3 points of intersection. So 1, 2 and 3. Okay, so 3 points of intersection, and they are at when x equals 0, x equals 3/5, and x equals -1. So the coordinates are 0, 0, 3/5 and 15, and -1, -1. So let's move on to part C. So C is now when the purple graph is greater than or equal to our red graph. So that's going to happen here. So that is when x is less than or equal to -1. Then it's below between -1 and 0. Then it goes above between 0 and 1. So between 0 and 1. It can't be 1 though, because that is an asymptote. And then it's above between 1 and 3/5. And then it's above then after 2. So when x is greater than 2. This one can be equal to the 3/5. So it can be equal at the points of intersection, but it can't be equal at the asymptotes. Okay, so we've got 4 regions. This region between these two values, this between these two values, and then between this value and infinity. So 4 regions there. Okay, so that is question 2 complete. Oh, hang on, it can be greater than or equal to 2 because that's the red asymptote, not the purple's asymptote. Okay, so it can be, greater than or equal to 2. You can use an equals there because there's no actual red graph at that point. Anyway, that is now question 2 complete. Let's have a look at question 3. So we need to sketch these. This is probably the easiest one of all. That should have been the first question really, rather than the last question, because these graphs are probably the easiest ones of all. So 1 over x, I think everyone knows what this looks like. Reciprocal graph, something. It is hard to sketch on this on my iPad. So that is the y equals 1 over x graph, and then in red we've got x over x plus 2. So we've got an asymptote here at -2, so vertical asymptote at -2. So that's at -2. And then where have we got a horizontal asymptote? So let's look at it. X over x plus 2. Divide through by x, we get 1 over 1 plus 2 over x. Now, as x tends towards infinity, this goes to 0, 1 over 1. So the asymptote is at 1. There. Now it's going to cross when x equals 0, y equals 0. this cross in here. So I think it's one that's going to look like this. It's going to come up, cross at 0, 0, and head towards that asymptote there. And then this one is going to head like this. Okay, so let's just double check. Like if I've got -1 in here, -1 over 1 is going to be a negative value, so it is going to be down there. If I've got a value above 0, so 1 over 3, so it is going to be a value here, so that works. Then let's look then either side, so the other side of -2, so -3. -3 over -1 is +3. If I put this -10, -10 over 8 is going to be a small value. It's going to be going down there. So that there makes sense. So I've sketched the graphs here. Now let's do part B, find the points of intersection. So 1 over x equals x over x plus 2. So x plus 2 equals x squared. So x squared minus x minus 2 equals 0. So x minus 2, x plus 1. Just double check. X squared, x minus 2x minus 1x, and that's minus 2. So x equals 2 or x equals -1. Now I can substitute them into here to find out the coordinates. So at 2 we've got y is a half, and at -1 we've got y is -1. Okay, and those kind of make sense. -1, -1. And then 2.5, bringing a value in less than 1. So those two points of intersection do make sense. Now let's move on to part C. So we want when 1 over x is greater than this. So 1 over x is our black graph. So we want when our black graph is greater than our red graph. So from -2 down, the red graph is greater, so that isn't going to help. Now, from -2 to the point of intersection, the black graph is above it. So from -2 to -1, okay, at that point of intersection, so that is one region where it's going to be above. And then where else the black is above, so it's from 0 to the other intersection point at 2. Okay, because then after there it goes below. And that is question 3 complete. As I said, as I was doing it, I realized that was the easiest of the 3 questions there, done at the end. So now you can go ahead and practice some more questions and hopefully get good at this. Like I said, you know, sometimes they will ask you to sketch it. So you will probably want to solve it this way. But if it just says solve, it's totally up to you how you go about doing that. Whether you start with a sketch, the points of intersection, and then using the sketch and the intersection points to say what regions are happening, or like we did in the last video, where you do it pretty much all algebraically with a little sketch at the end just to help you sort out the regions. that will be totally up to you if the question allows. Otherwise, if it asks you to sketch the graph first and find the points of intersection and then solve, it makes sense to do it this way rather than the way we did it in the last video. Okay, so that's it for me today. Don't forget to like, subscribe and join. Otherwise, I'll see you in the next one.